Can everyone see the PowerPoint presentation? Yeah.
Right.
Okay, so let's begin. Welcome everyone. It's very nice to see so many familiar faces. Today we're having our second Amphora event, Revolutionizing Tank and Silo Design and introducing Amphora's new developments.
There's someone unmuted. I don't know if we can. Can everyone please make sure that they're muted because it gives a lot of background noise.
Yeah.
Thank you.
Thank you. So let's begin. Today in the agenda, we have first the goals of this event, an introduction on Amphora and Solico, Amphora key advantages, the EN 13121 standard. We're going to showcase our new developments, give you a demo. We're going to also talk about subscription options, and at the end, we're going to have a Q&A session. Now, for the goals of these events are first to elaborate on the new Amphora functionalities, to showcase her current abilities, to guide her. Oh, sorry, there's someone trying to join. Yeah. To guide her existing clients through the Amphora engineering process as well as new customers, and at last, to showcase her new development strategy. Before we dive a little bit deeper into Amphora, I would like to make an introduction to Solico. So Solico is the world's largest independent composite engineering company. We do composite engineering, and we also have an in-house lab where we conduct testing. Our team is composed of 27 engineers with over 150 years of combined experience, and we have worked on over 4,000 projects. It is important for you to know that Amphora is an internal project of Solico. So a lot of people tend to think that Amphora is a company, but really Amphora is just a small part of something that is much bigger, which is Solico. Oh, someone else is trying to join. Okay. No, sorry. Like I said before, our team is composed of 27 engineers, but we also have our Amphora team, which is composed of 7 colleagues. That would be Dante, our Amphora specialist, Koen, our Amphora manager. I am a part of the Amphora commercial team. We have Peter, which is the original Amphora creator, Stefan and Diego, who are our engineers. And at last, we have Jasper, who is our external data scientist, and that help us make everything possible. So thank you, Jasper, for your work. So now Koen will elaborate a little bit further on what we do.
Sorry to interrupt. I think the recording just stopped.
Oh. Sorry, guys. The recording stopped for some reason. Oh, no. Oh, it's coming up.
That's working.
Yeah. It's perfect. So.
All right. I'm going to very briefly tell you a little bit, for those who are not aware, what Solico is and does. Of course, we're focusing on Amphora, so I'm not going to make it too long, I hope. But essentially, what we do is we are composite structural engineers. So the team of 27, as Karina addressed, focuses 85% of their time on structural engineering. So in a typical vessel, as shown here on the left side, we actually simulate computer simulations mostly, for example, an internal bulkhead or the vessel itself, or many other things. And we can predict deflections under load, strength, load at failure, etc. As I said, that's about 85% of our time that we're spending on. We also have an in-house test lab, which you can see on the right side. And in the lab, we are able to conduct all sorts of destructive tests on composites, mostly to determine the material properties. And we also have the abilities to conduct a significant number of non-destructive tests. Sorry for that. All right. Some of you may know, but maybe not everyone. Our biggest market is defense. And within defense, we are mostly focusing on naval projects. As you can see, the submarines, frigates, and fast-moving vessels. But as of 2021, I believe, we also started working for the Dutch land forces. Most of the defense is for the Dutch Ministry of Defense, where we are, what I believe, a preferred supplier. But also, we also work for other defense units within Europe. Personally, I am responsible for the maritime business unit, aside from my tasks at Amphora. So this is a little bit of my baby. On the right side, you see some super yachts that we've done a lot of work on. And on the left side, you see, for example, a small foiling vessel, which we developed completely from scratch. And you see a commercial vessel, which is a ferry in Copenhagen, for which we did a lot of composite components. Then the third business unit that we actually are active in is civil and architecture, where we do many bridges. We automated a lot of software for bridge design, which has enabled us to do about 700 or more physical bridges. And aside from that, we have 30 or 35 facades throughout Europe and outside of Europe, actually. I'm not going to go into too much detail, as mentioned, so I'm going to skip the rest. Of course, composites are often used in the roller coaster industry, theme park industry, I should say, which is something that we're focusing on for the future. And bottom left, I think that the people attending to this presentation, there's going to be some connection. This is one of our clients called Plasticon, where we actually did the structural engineering for a gas duct in Germany. And this typical gas duct has a diameter of 12 meters, I think.
Around about, yes.
Yeah, 12 meters and unsupported spans of 70 or more meters. So engineering-wise, these are quite challenging, quite demanding. And again, we've done around 35 of these throughout the globe, ranging from China to USA. So that's a little bit about our business units. Shall I give the mouse to you, Dante?
Yes, thank you. Good. Thanks for the elaborate explanation of what it is we do, apart from Amphora. But enough about the rest. Let's talk Amphora now. First question. Back in the day, when Amphora was first launched by my colleague Peter, it was him who actually thought of a suitable name for the program. But do any of our clients actually think to know what Amphora stands for? I see no immediate reaction.
Yeah, we do. It's a Greek, thing to put wine into. So
yes, you're completely right. So thank you. It's old Greek for a vase with two handles for transport of oil and wine. So I think it's a very suitable name for Amphora as we know it today. I'm actually surprised that some of you actually took the time to find that out. Thank you. But of course, today, for us today, we know Amphora as a calculation tool for GRP tanks and silos, right? Because that's why we're having this meeting today. The original version was developed back in the year 2000 as a standalone version, because of course your computer's life was a little bit different back then. You had to install the program on your computer. You had a dongle for each license. Some of our clients may vividly remember that. But with coming into place the new EN 13121 standard back in 2016, we decided, okay, we need to build a new program. We're going to update it. Of course, according to this new standard, which is both government regulation in Britain and the rest of Europe. We wanted to have it web-based because that provides various advantages to us, but not in the least to you guys. And of course, it makes licensing a lot easier. and it would have extensive reporting capabilities, and of course the licensing, in the different languages for report writing. I'm going to list some key advantages now. There are two facets. There are technical advantages, but there are also commercial advantages. Depending on your background, you'll be interested in one of both, I guess. Technically, of course, the ones that have worked with Amphora know there's a central material database for each client, where you can enter your laminate and your resin properties. It's a fabulous way actually to reduce errors, because if you have to do that on a daily basis, or I don't know, my colleague has to do it and I do it, maybe I use different numbers, and then you get into a discussion. No, there's no discussion here. There's one database, one set of variables which you work with, which everybody in your organization can actually work with. And of course, the same goes for the projects. You can access all the projects you've worked on with Amphora, from the worst to the last, from the first to the last of them, which is of course good to keep track on what you've been doing. Of course, apart from that, there's also the on-screen reporting, which makes it very easy for you guys to actually have an overview of how your design is performing. You get a percentage of use in structural use of each of the sections of your tank or silo. And of course, once you're pleased with that result, you can actually download the report, which you can then submit directly to your client or to a governing body, reducing, of course, the amount of paperwork that you need to do yourself. Another advantage is, of course, that there's a wide variety of geometric configurations possible in Amphora. Basically, all configurations that are possible within the limits of the EN standard are configurable within Amphora. So that's a huge advantage as well, as we'll discuss later on. We also have the built-in wind and snow load calculation. So we decided to incorporate that for Benelux, Germany, and France, because that's where our main clients were at the time. Of course, you can use it everywhere as long as but then you have to calculate the wind and snow load separately. Of course, that can be updated as we progress. A major advantage, I think, for you guys is that we, of course, guarantee that it's always up to date with the latest version of the EN standard. We know that people are working on a new version. It's way down the future still, but we know that there's being work on that, and we'll be one of the first to know, hopefully, when that new standard arrives. And of course, Solico can always help you out, right? So it's important to know when you ask us, when you make a project in Amphora, you can always pick up the phone, send us an email, and ask, okay, I'm working on this project, it's this number, can you have a look at it? We can discuss it together. I can see what you've been doing, I can see the material properties you've been using. We can help you out wherever you want, which is, of course, as Karina rightfully stated, it's the engineering is our core business. So I think that's one of the main advantages for you guys. Of course, there are also commercial people involved. That's the sad way of life. Sorry. But of course, also commercially, Amphora has various advantages. It can be adapted to our clients' needs. And I know for a fact that there's at least one client here today that has a special feature embedded in Amphora that suits their own needs. So we can do that. It's basically just a question of whether or not it's desired or not. So that's one of the main advantages.
Maybe it's good to add to that. If you just go to the previous slide, we will ask you all later a question whether you have specific development requirements, and depending on the amount of requests we get, we will develop Amphora towards a certain direction. If there's a specific one-off requirement that only you want, we can look at developing that bespokely for you as well.
Exactly. Of course, A further development, further advantage is, of course, the database for within one organization. You can use it for multiple users. And of course, biggest advantage is that even a non-expert, because I consider all of you experts, but even a non-expert can basically make a structural design or a tank or a silo in 10 minutes.
I'm going to prove it.
Yes, my colleague Koen will demonstrate that later on. And yeah, as he said, he's a business unit manager, so he's not into all the finest details of what is this all about. So we'll be judging him on that later on. But of course, yeah, this provides a huge time advantage also for non-technical people, commercial people who can also have a go with Amphora. Because of course, this has the advantage of reducing the risk that there are wrong quotations made or that material cost is higher than expected. And of course, added to that, Amphora has the optimization function, so you can really optimize your laminate thicknesses to the limit of what is within the standard possible. And of course, the by far reduced paperwork of being able to download the engineering reports directly from Amphora with one click of a button. That's also a huge advantage, well, at least from my perspective. But okay, as said, with Amphora, you can design a tank or a silo within 10 minutes, which is fully compliant with the EN 13121 standard. It's a standard, both the European and British standard, because they're exactly the same. But of course, it's important for you to know that this is this particular EN standard is a part of a complete ecosystem of EN standards. And so it basically works within a set environment of EN standards. Of course, it takes a while to familiarize yourself with this standard. And of course, like every standard, it refers to a zillion other different standards, which you would have to know your way around to as well. Of course, for us at Solico, this is a daily part of our job, basically. For example, for a calculation of a silo in a seismic region, you need to know your way around at least 7 standards before you can actually design the thing. And of course, just to bring into perspective what it is that Amphora is capable of doing and what it is that we provide as a service. Because that's the main reason we developed Amphora. In this part of the presentation, I will guide you through the basic guidelines of the EN 13121 and the design process. Of course, all the other standards, I assume that you all know them by heart, just like we do. Basically, tank and silo design, in the end, you start with determining the material properties, setting up your material reduction factors, determine the loads and the combinations you need to take into account, and then you basically work your way through the design of your silo from top to bottom. So you make the calculations of the cover, you analyze the cylinder, and the bottom, and then cutouts. And when it's then finished, you can actually anchor it to the ground, which of course also has to be analyzed. So we're going to shortly, because I don't want to keep us here all night, we're going through this process in a relatively short manner.
Sorry to interrupt you, Dante. It may be worth knowing that for specific clients, we have given courses and trainings what the EN 13121 standard is about. Typically, a standard license doesn't include such reservation. However, if you really want us to, of course, we will try to support you and try to explain to you how to design or build a tank or silo in the standard.
Yes.
Sorry.
No. It's basically it's what we do, and it's knowledge that is common ground here. So we're happy to do that. So first of all, of course, after you determine all the external loads, because basically, let us assume that you are building a vessel somewhere here in the Netherlands. You know where it is, you know whether or not there will be wind loads and what snow load you need to apply, and then the seismic loads. You've all done that. That takes you through a couple of different standards, of course, before you can actually start. But let us assume you've all done that, and then now we can actually start working with the EN standard. And we're going to do that by determining the material properties you're actually using to build your vessel. Yeah, as you can see, there's quite a lot of numbers involved. I'm not going to go into detail because that will take us way off topic here. But basically, you can either calculate the material properties of your laminate through table 3 of the standard, or you can go through an extensive testing program and determine the properties yourself. That's basically the two options there are.
And we can help with the tests.
And we can do those tests for you. So that's basically a win-win as far as I'm concerned. Note, if you calculate the properties through the table, that basically you'll see that only the grammage of fibers, so the amount of fibers that you use, is actually taken into account. In principle, these properties are not not dependent on the type and amount of resin you're actually putting in there. That's strength and stiffness, but apart from that, for a tank, of course, you also need to do a strain calculation because there's a strain limit set by the standard. These strain limits do, however, depend on the type of resin you see. That's the table on the right. Well, it's on my right, so I think it's on your right as well. And note that the only extra additional limit there is that it's the strains in the table are standard strains for standard, for example, polyester resin. But if you use a particular resin system with a lower failure strain, then the strain limit will be at 10% of the failure strain of the resin itself. Now, we all know our material factor, well, material properties. Let's now see which reduction factors we actually need to apply in our design. There's quite a few of them. There's a total of 6 reduction factors we need to apply and determine, of course, before we can start. And there's the gamma M, which is basically a reduction factor because of the spread on your material properties. Then there's the A1 factor, very well known to most of you, because it depends on the origin of your material properties. So either you calculate through table 3, or you go through an extensive testing program that has an influence on the A2 factor, which has a range between 1 and 2, and has to be set according to table 8, which is on the left side of your screen right now. Then you have A2 and A3. Those have to be determined through section part 2 of the EN 13121 standard. And they're basically depending on the type of resin you use in combination with the medium which is inside the vessel. A4 takes into account variable loads. Let's say they're almost fatigue loads, let's say. So that's outside the scope of this standard. So in the EN 13121, it's always equal to 1. And then there's the A5 factor. That's again the test we can help you with, because the A5 factor actually takes into account the creep behavior, so the behavior of your composite material under long duration load into account. And these factors can either be used, you can use the ones from the standard, but they can also be they can be determined based on tests, of course.
And typically, tested values are significantly better than the standard, or?
No, I actually think that the values in that aspect, the A5 factor and the EN are quite okay.
And the others?
Yeah, of course, I think the material properties tend to be a little bit on the conservative side, as with most standards. But I guess the biggest influence that doing the tests or not performing tests is basically the A1 factor and the combination. Because let's say that we've determined all of our 6 factors. Now you need to also comply with the minimum reduction factor, which is K for strength and F for stability. And that also depends on where your material properties come from. So basically, I have calculated my my properties through table 3. I've done just a test to see whether or not I meet these minimum requirements. Then I need to apply a minimum reduction factor of 8. K is minimum 8 on the right side of the table, on the left side of the and of course, if I have done an extensive testing program, I know my values, I know all of my factors, they're tested, there's a quality assurance program on your production, then your K is only 4. So basically, just by performing or not performing the test standards, your tank becomes twice as thick. That's very important for you guys to realize. That being said, let us now assume that we all have what is okay. Let us say, okay, now we have our mechanical properties, we have our reduction factors. Now we need to devise the loads and the load combinations. As said, the EN standard is a part of the complete EN standard environment. So the loads you will have to calculate through the specific national annexes of the EN, snow, wind, earth, seismic, things like that, and then combine them as prescribed in the EN 1990. Luckily for you, most of these things are summarized in the EN standard. In essence, you need to combine all possible combinations. For example, let's say you need to combine a wind load with a full tank with its self weight. But of course, you do not need to combine a live load on a roof with snow load, because that would mean there's 1 meter or 1.5 meters of snow on the roof, and obviously then you can't access it. So that's those are a few combinations you can't make. But in essence, you have to check all other possible load combinations. Note that like in the EN 1990, each load, depending on the duration, has its own load factor. And of course, don't forget the A5 factors, also depending on the load duration. And then you have to make different combinations for strength, strain, and the stability check. So those are quite a few checks you need to perform. And of course, if you combine multiple short duration loads, let me see, like a wind load and a live load, then you need to add a combination factor, because that you cannot. It would be unfair to combine them all with a factor of 1. But as said, it's quite a lot of bookkeeping, which Amphora luckily does for you. Now we know our loads, we know our material factors, we know our material properties. Now we can actually start designing our tank or our silo, and we do that basically from top to bottom. We start with the design of the cover. Again, some formulas. So on the left-hand side, this is the example of a calculation of a dished end. You guys know what I'm talking about, of course. It depends on the radius of the knuckle, the radius of the. And now I can only remember the German word. Yeah, but the cover is basically has 2 parts. It has the crown and the knuckle. Thank you, Koen. And depending on the radius in each section, of course, you need to calculate different loads. We basically calculate we transform all the pressures into membrane forces, and then we're going to check, okay, the occurring membrane force is such, and then we know that what our material properties are, so we know basically the allowable version, the allowable strengths, which we then have to reduce with all our material factors we've determined, and then we can see whether or not our design is okay, or we have to increase the thickness of our component. Since I don't want to bore you all to death, the bottom of a tank, because this is a hemispherical or another type of dished end on the top of your tank or silo. Of course, if you apply this, you apply these same formulas for the bottom, if it would be a dished end bottom. So I'm not going to repeat that for the bottoms, but this is the way it basically works. Now we have our cover designed. We get to the cylinder, and like all the other sections I talk about, we check this on strength, on strain, and on stability. But there's one big difference here. The cylinder is usually, I say usually because there are clients who do this differently, but usually use a winding technique to actually produce this section of your vessel, which means it has different properties in axial and in transverse direction. So that also means that we have to do all of the checks and all the load combinations we've talked about earlier. You have to do them differently for axial and transverse direction. So even more bookkeeping. And again, we have Amphora to do that for us, luckily. The most particular part of the cylinder design is actually the buckling of your cylinder, because you all want to minimize cost and therefore optimize the thickness along the length of the cylinder. That means you will have different thicknesses over the height of your cylinder. Now, for example, you have a 10-meter high tank and you want to make different thicknesses every 2 meters, so it means you have 5 different sections of your tank. We have to reduce those. We have formulas to do that by a German standard, which I'm not going to talk about here today. We have to reduce that to a 3-step cylinder. And of course, this is directly involving the stability of your cylinder. So the optimization of your cylinder wall is particularly complicated. In the beginning, we developed Amphora, we had some issues. We have improved our optimization routine significantly over time to minimize these effects, but still it's quite a challenge. Now, one of the things we deployed today is actually the rib stiffened tank, because I talked about thicknesses that vary stepwise over the length of your cylinder. But of course, another variant, especially valid for larger diameter tanks, is of course the rib stiffened version. Basically, this is equal to a regular cylinder, but there's the difference lies in the stability, the circumferential stability calculation, because you calculate the local stability in between the cylinders. So that's basically depending on the wall thicknesses in between. I said cylinders, I meant ribs, of course, in between the ribs. And of course, the global stability of your whole tank is determined by the combination of wall thickness and the rib design. So that's one of the exciting things we deployed here today, fully functional and also report-wise, everything working order. Now, we have a vessel with a cover, a cylinder, and a bottom. Now, and there's some guy telling you, yeah, but I need a connection to connect my tube to, so I need to start sawing holes in my cylinder. So that's an added problem, of course. Luckily, the N also provides calculations for that. I mean, you can calculate basically everything. That's our job. But again, that's more bookkeeping, keeping track of everything. And that's also one of the things we present here today. As of today, each vessel, each cylinder can have cutouts added, and Amphora will calculate the compensation laminate thicknesses all by itself. How does it actually do that? Well, depending on the relation between the diameter of the hole you actually make into the cylinder and the cylinder diameter itself, there's like a penalty factor, let's say, on the loads that are actually already present into the cylinder wall. And so, yeah, a regular hole in a normal tensile stress field is a factor of 3, more or less. So you increase the loads, and then you base your compensation laminate, you base on that. And not only does Amphora calculate the compensation laminate so that your cylinder wall is actually still structurally valid, but it also calculates the pull-out forces due to the pressure. Of course, your flange wants to be pulled out of your cylinder wall, so it also calculates the minimum amount of laminate you need to put there so that it doesn't shoot away like a projectile. now that we're finally done with all of our tank stuff, we can actually anchor it to the ground. And of course, there's more calculations in there, depending on, of course, irregular loads, wind overturning moments, seismic moments. But also, if you have a flat bottom tank, you also need to anchor it to the ground such that the upward pressure of your internal pressure doesn't lift it off the ground because your bottom isn't stiff enough, things like that. That's also something Amphora does, of course. And then it calculates depending on, there's a few anchoring solutions you can actually choose for each vessel. It calculates, for example, for a bolted anchor, it calculates the bearing stresses in the bolt connection. So you use the right type of bolts, the right amount of bolts, or when it's a laminated anchor, you use the right amount, the right thickness of laminate, or the right size of anchor. So that's all incorporated here. And if I'm not mistaken, I can now give the word back to my colleague. I hope that my story has been clear to all of you. I know there's a lot of knowledge behind my slides, but I didn't want to go into. I've skipped a ton of details, of course, but that would lead us way too far for this presentation, I guess. And if there are any questions, please reach out to me in another time. Go ahead, Koen.
Yeah, thank you. I just briefly wanted to give you insight on what we have in mind that Amphora will be used for. It's quite obvious that, of course, a design or engineering facility in a filament winding company or in a tank or silo company will use Amphora in our perspective, but it doesn't really end there. We often see that the sales department have sold something and then apparently they were really pressured to get the price down to win the contract, and as a result they're struggling a bit to make the budget of a tank or silo work. For that reason, we believe that all sales teams or tendering teams or whatever you want to call them should be working with Amphora, because I'm going to prove to you in a minute that I can, in less than 10 minutes, make a very good rough estimate. And of course, I do have a little bit of a technical background, but I have absolutely no experience in tank or silo design. So in that sense, I think that I can be quite representable for a sales team. We also, it's also worth mentioning that we see very large industrial companies that use composite tanks or silos also use our software. And the reason why they use it is they actually want to check their suppliers if what they are providing is going to be okay. So they use it as a tool for validation. So it's not only the design and engineering office within a production facility that we think should be using this, but it's more than that. So I really encourage everyone to tell everyone about Amphora, because we think it is the holy grail. So it has already been defined, and I think everyone is aware, but just to summarize, Amphora is currently capable of doing vertical tanks, silos, and we newly developed the rib-stiffened vessels. So rib-stiffened vessels are mostly for large diameters. Typically, we would say 4.5, 5 meters upwards.
Yeah, it depends a little bit on your personal production. Yeah,
as a rough order of magnitude. We also released the cutout module that everyone who uses Amphora will have access to for all types of vessels. Lastly, this has already been deployed a few months ago, but we have the ability to report not only in English but also in German, because we have a lot of German clientele. Demo, but then I don't know if it's on the Chrome already.
Yes.
You already prepared it. Great. So I'm going to be open and honest with everyone. This has not been prepared. This is, I don't have a cheat list. I don't have a cheat sheet. The only thing I told Dante is if I really fill in stupid values, just help me a little bit. But I'm going to see what I can do. So what I typically do is I start a new project. I am already logged in, of course. So, well, actually, Dante is logged in,
Yes.
but that doesn't create any difference. Create a new project, right?
Yes. Of course, prior to doing this, you would generally first build your material database, but let us assume that I already did that.
Yeah, there is a material. I know that you have a material database already filled in because we have shown this before to some people. So there's a number of materials already filled in. I can edit those materials. I can add new materials here. And as Dante mentioned, everyone should have all the materials tested because it's going to make your tank or silo half the thickness. So going back to projects, I'm going to create a new project. I'm going to call it, let's say, Koen for President. And it is going to be a vertical tank. The length of the cylinder, let's make it 8 meter. With a diameter of, let's do something, 3 meter diameter. I can make a description. Just as an internal note, create project. So now I have created my Koen for President vertical tank, and I can edit that. And just like Dante prescribed, from cover to bottom, that is the approach that you have in Amphora. So I can select what type of cover I want to make. I'm going to select a torus spherical. Not that I really know what the differences are, but I have to start somewhere. It is ventilated because I know that if you actually empty it, that it will suck vacuum. So I think that's always helpful, even though it does consider the vacuum pressure that would occur. Cover material, I'm going to build it from hand laminate. I already identified 8 meters length, 3 meters diameter. Volume, I don't think I have to fill in. It calculates it by.
No, you don't have to, but if it's deviating from, let's say, the maximum geometric volume, then you fill it in.
So I don't have to fill it in.
No.
Cylinder material, let's put a winding laminate. This is Dutch for winding laminate for those. Bottom, well, I have the torus spherical at the top. I'm going to take the same for the bottom. With a bottom material of material dummy.
Yeah, this is my testing account. So
I'm going to take a hand laminate for the bottom. It is on a fully supported skirt with 3 meter length. It can have an opening in it, but 200 millimeter opening, 500 millimeter opening. Support material. Sorry, door portal stiffness. I don't think I need to provide that at the moment because it's only 500 millimeter. Anchoring for uplift, anchoring bracket laminated. Well, you can just pick any bracket you want. Let's take that bracket.
Note that Amphora will make a pre-selection based on, for example, for a fully supported skirt, there are other anchoring possibilities available than, for example, flat bottom and membrane design. But again, if you have a combination that Amphora doesn't allow us for, please just send us an email, because maybe we're making restrictions where you have found an intelligent solution to. So.
Thickness of overlaminate, I'm just going to take something, 15 millimeter anchoring width of overlaminate, 200.
Wow.
Shear surface of overlaminate, I think that calculates automatically.
No, because it's difficult. It's the hashed area in the graph.
Yeah, I know what it is. So 40,000. Compensation laminate for cutouts. That's going to be a hand laminate. Then I have to press update.
No, you didn't actually fill in.
I saw, and I didn't fill in the bottom here. Branch diameter 80. I haven't tried this. This is the new cutout.
Yes.
I'm not going to fill in the description. It's going to be crown of bottom. I have to press insert.
Yes.
Yes. Now it okay. Update. Loads. I need to apply loads. Type of medium water. It's very heavy water. 40 degrees. I can fill in design pressures. I know that Amphora fills this in automatically if I don't fill it in, right?
Exactly. You can't ever fill in 0 because the standard won't allow you to. So even if you fill in 0, Amphora will always calculate with minimum value.
But if your client says, no, I want 0.1 bar, then, or 0.01 bar, then you can just manually adjust it.
Yes.
Live load on cover. This is typically, I believe,
That's basically the same story.
yeah, there's a minimum, so I don't need to fill it in unless there's a specific requirement. Additional mass, if there's a ladder on the side, I know that I can actually apply it here, right?
Yeah, or something heavy.
Something specific. I'm going to skip that. Wind and slow. So the standard settings are Belgium, Luxembourg, Netherlands, France, Germany, or user input. So it can be anywhere in the globe, but then you'll need to look it up. If we have specific requests that are reoccurring, we can actually add it to this list. Let's take Netherlands. Wind zone 1. So this is depending on how much wind it is exposed to. I think everyone is aware. Terrain category, similar circumstance. Wind force coefficient, standard.
Yes.
Seismic.
Yeah, there's actually only one seismic zone in the Netherlands, so I wouldn't fill that in for now.
Okay. I always have to press update, and then I think laminate thickness. I could just press evaluate, right?
There's a small portion you still need to fill in because you need to fill in the general data because you haven't selected, for example, a resin system yet.
Yes, but where is that?
Yeah, in the laminate thickness page, first part.
Yes. Oh, so I should actually go logically through all the pages.
Yes.
But that would make sense. Isopolyester, which is cured in an insulated tank with A2 factor. Well, that's always going to be 1.0.
Maybe.
CRL on the inside, thickness, chemical protection layer, 1 millimeter. Optimize. So basically what it has calculated is that we need between the height of 7 and 8 meters, we need 7 modules. And as we go further down, we see that it increases in requirements of the modules needed. Our modules are currently 1 millimeter thick, so ultimately there's a one-on-one equivalence to the number of modules and the thickness. So I actually made the tank design in round about 10 minutes.
13 minutes, yes.
And
now if you click evaluate.
Yeah, the same comes up for the bottom, for the support. If I press evaluate, I'm going to get the on-screen report.
Yes.
And the on-screen report will give me a very good indication of my utilization factors, like here. And it's more or less all written out, so you can optimize it to your liking if you want to optimize it further. But we believe that it already optimizes it to the absolute limit.
There's one thing I wanted to mention. Some of you might see that now all the results are in green. That's a client request I updated. I think it was yesterday. So it gives you, if there is something, some of those numbers are in red, then you know you're in trouble. So you can immediately see where the problem is. So that's an addition we made. Yes.
I'm sorry. So the on-screen report shows you a lot of details on the actual design. It gives you all the details needed, and I think that everyone within a production facility will be able to work this out. In the event that you need to submit any written documentation, there's the button download full report. So yeah, I love that. So this is the actual downloadable report. So it creates a PDF that you can save and submit to any authorities. And basically it has the same content as the on-screen report, but it is formatted to make it better readable for PDFs, for printed PDFs.
Yeah, and all the formulas used are also in there.
So I suspect that there may be questions coming, but I would like to finish, I think, the last slide or last two slides of the presentation, which will be here. Yeah, just to sum up, in green, you see the modules that we have developed. So we have got the silo module, we got the vertical tank modules, cutouts are working, rib stiffened vessels are working, German has been deployed. So we made a huge amount of progress. We sense, based on some requests coming in, that we would potentially include a costing estimator, a weight estimator. We are considering developing a horizontal tank module and revisions to Eurocodes. So that is what we have as a potential roadmap, but we're also going to ask you for a little bit of feedback, because with this QR code, or by going to the website and filling in the number that you see at the bottom of the screen, you can actually answer our poll, because we're trying to identify what are the demands, what are the requirements. So yeah, maybe you can help me, Karina.
Yeah, so if you scan the QR code, I will start the poll.
Oh, you need to press start.
Yeah.
Ah.
Because I need to.
So we see that maybe we can just put this live on the screen, because it's all you can't see who's actually answering, but we see that I think everyone can see now that we are getting in feedback. So we have spray up, hand lay up, and open filament winding. So 3 people have actually answered so far, I think, based on the little number at the bottom right.
There's some more coming in.
Maybe we should actually keep on the Menti code, because I guess that people can't see that. Nope. I didn't think about that. Sorry.
Maybe it's on purpose.
Can we make it smaller and put it on the side here so we can? Don't know if it fits.
Yeah. On the cover, just we'll keep it like this.
There's room for improvement for the next time. We're going to move the QR code a bit to the side. We've got 5 people who filled it in so far, and we see that filament winding, not a surprise, is the biggest player in our field. If we go to the next slide, because I think that those people will probably have already filled in the typical. Oh yeah, they can fill it in now, right? Because you switch to the next. So we see some results coming in. So currently Germany is in the lead significantly. I'm actually surprised that the rest of Europe is quite well represented as well. And actually France, Belgium, Netherlands, Luxembourg are actually lagging a bit. So I see what we're going to have to do with the national annexes.
Yes.
Now
All right.
moving on to the next one.
Typical diameter. And yeah, everyone will. So now everyone can see for themselves. We don't need to lively report.
As Koen mentioned, of course, this is. It's very good for us to know what it is you guys are actually doing, and in which this helps us knowing the direction in which we need to develop Amphora further in the future.
I'm happy to see that there's actually quite a lot people busy with larger than 4 meter. Actually justifies the rib stiffened vessels.
Yes.
Okay. I saw this video on LinkedIn of an Australian company having a horizontal tank, and they had 50 ribs on the vessel. Unfortunately, they're not here, but I hope that they become Amphora users at some point as well. I think
Was it
there's
an
only some
underground vessel?
It didn't say. It was for water storage. It could be an underground vessel, but I don't know. But it was so incredibly many stiffeners that I was like, wow, this. I can imagine that optimization is possible. I think there's only 6, right? So yeah.
And the last slide.
For us, this is the most important one. This is really the one where I understand you need to put the time because you need to put it in priority. But what do you think is important? Horizontal tanks, I think, speaks for itself. Weight, cost speaks for itself. So we mentioned visualized list of thicknesses. We hope that maybe that will help production companies. So that is something that if you want that, we could make a visualized list of the thicknesses required. Of course, lifting nozzle loads, that speaks for itself, I think. And then language developments. Now that we have German as a possibility, adding new languages should be fairly quick.
Yes.
Oh, wow. So the sales team is going to be using Amphora in the future too. That's good. I like that. 3 responses so far. I hope that we can get 4 responses. Oh. Sales team is not going to be.
I'm actually quite surprised at how this is going, but okay.
How many more of these poll slides do we have? That's it.
Yeah.
All right. Because I think we're waiting for one more person because we got 5 responses. I also see that we don't need to develop lifting.
Oh. Cost. Yeah.
Cost. So actually cost did pop up back up. Well, that's a very clear answer. I really appreciate this. Thank you very much all for your efforts in this. And I think that brings us to the last slide. Yeah, I think everyone is already aware because I think I had the most spoken to most of the people present. So I'm not going to go into the details. I've already told you what the capabilities are. I think everyone's aware of the financial impact. So and then we get to the very last slide, which is questions. So technical questions, I'm going to step aside and leave the floor to Dante. But Karina and I can pick up the remainder, I hope. Anyone? Oh,
Question.
that's
Yes.
that's good. Oh.
Yeah, I have a question. Sorry for the
Yes,
late.
Go ahead, Richard.
Yeah, silicone skirt with weighing system and a door. I'm not sure with I'm not sure how to fill it out always.
Yeah. I have to be a little bit political about this. Yeah, first of all, it depends largely on where is it for, because we had some discussions with the German authorities. If there is a door, for example, in the skirt of the silo, then we need to do a very extensive non-linear sensitivity analysis.
Mm-hmm. But in the rest of Europe?
In the rest of Europe, you've seen that when Koen actually made his project, you can actually put in the width of a door opening there.
Which project?
The Koen, oh my God. The Koen for President project, you can actually fit in a width of a door there, and then you have to add the stiffness of your door frame, right? So it takes that into account to calculate the actual stability of your skirt, and then you have a fully supported skirt with a door. Now, if your silo is on a weighing system, that's mostly 4 weighing cells. there's a problem, because you could do, for example, I'm just thinking out loud, Richard, you could do, I think then you need to use Amphora in a way that it's not completely intended to, but you could do that, I guess. Put the, I'm actually thinking that it's not possible, I guess, because normally what I would do is use a short skirt setup on 4 support legs.
Mhm.
Of course, that will make your skirt very thick, because you will get the huge loads localized in 4 support points. Because I know that most of you who use load cells, don't put the load cells under the skirt directly. No, you use a steel frame in combination with the load cells to actually support the skirt. So if you do it with the short skirt system, it will result in very high thicknesses. Problem with the short skirt method would be that you cannot incorporate a door. So maybe first conclusion of this discussion would be to make the for support option available in the fully supported, the not fully supported skirt version then.
Right.
Yeah, we use it a lot.
Yeah.
All the silos we sell on skirts, client wants to weigh them.
Yeah, and I get that.
Is this specific for you, or are there other parties that have similar issues?
Must be.
Okay.
Yeah, I assume some of the guys present today have this similar issue, but okay.
Okay.
Maybe
Thank you,
Ruben has.
Richard.
Yeah, you're welcome.
Any other questions?
Or suggestions, yes, those are also welcome, because obviously in our poll we presented things we think about, but okay, we are not you. We're not in this this world. Yeah, that came out wrong. I mean, you guys have close contact with your clients. You know what is what future developments will hold. So it would be great to hear from you as well. Hey, have you thought about implementing this or adding this, or this functionality would be great, something like that.
Can
I have
join?
a.
Okay.
I will wait.
Please go ahead.
Okay, I had one more question, and that's so what we see is that for us it would be very convenient if you could copy projects. So if we start a new project, that we could start from, let's say, or a template or a copy of an existing project. Is that something that's on the roadmap?
I see Jasper nodding. Yes, that's something that is on our list. Of course, we had other priorities prior to this day, let's say, but it's something we are definitely counting on taking into account.
It's even more. It's not only copying projects, but we're also trying to create a filter, so you can easily search or filter your projects that you have already entered in Amphora before. We hope that will help finding which project you previously had, which was very similar.
Yeah, because some of you have been very busy, and I guess that finding your projects now is getting a little bit more difficult.
There were more questions, but
Stanislav, yes.
Yep. I have two actually. The first one is, and we've been discussing this with Dante during the past couple of months. If you have agitators in a tank, and especially in a case where the medium is a little bit thicker, maybe you could, I know the answer, this is not taken care of in the Euro standard, but on the other hand, you normally in a tank have this, so you could think in that direction. And the second one, I saw horizontal tanks in the future developments, but on the other hand, you have gas ducts. I've been designing a few of them, last years, and it's kind of a horizontal tank, but not exactly. Do you foresee including gas ducts in Amphora for in the future? Thank you.
Yeah, typically, if I think we're going to say the same thing. We have done 30, 35 gas ducts up to biggest one was 14-meter diameter.
Yeah.
Vertical and horizontal. And from our experience, this set of load cases and requirements are so specific, and it has so many specific appendages and so specific supporting systems. I struggle to see, without knowing the EN standard too well, I struggle to see that you can actually incorporate such complexity in Amphora at a competitive rate. Because I think that everything is possible. We can develop everything we want, but it's not something that we can develop in a reasonable number of hours, I think.
Yep.
You agree?
Let's just continue on that a little bit. Of course, a gas duct has many curves. But maybe for the straight parts, when you can have a diameter and a span, it could be made a module that will, just speed up the design a little bit, and then the designer should take care of the rest of it.
What I suggest, we write it down. We actually wrote it down already, and we can discuss that separately to see how we can work such a thing out.
I wanted to refer to your first question regarding the agitators. What is it actually, in essence, that you would like Amphora to be able to do?
If we take just thinking out loud now, to take the load concentration factor we have, for example, for the compensation laminate. Maybe there is a way to kind of estimate the impact of the agitator on the global design. I don't know. I'm just thinking out loud. I understand it is not part of the standard and so on.
No, but I think it was in our poll, to be honest. That has to do with agitator loads, because with nozzle loads, because your agitator, of course, it exerts an actual thrust, bending moments, torsional force on your flanges, and that is something. We are asked quite frequently, to be honest. At this point in time. For us, that means you are building a finite element model and applying the loads as such. We could discuss this internally, whether or not it makes sense or how to, if there is a sensible way, because that's one of the requirements, of course, to say, as you rightfully state, this is not something that is prescribed in the EN. Therefore, we would have to devise our own calculation method to analyze connection laminates, things like that, and of course the effect on the cylinder wall, let's say. So that probably quite a lot of work. It's not saying that we couldn't, but we would have to have an internal discussion about how to go about this and if it would make any sense.
Yeah, we try to stick to the EN 13 1-to-1, but we see that more and more clients are asking us questions that are they're not pushing the limits. They're not according to the standard. So we have been discussing internally whether we should add a specific remark as soon as it's not according to the standard, that you can still calculate it, but it's very clear that it's not according to the standard. It is one of the conversations, and it's a little bit the discussion of what is your core value.
I was about to say that. I mean, you can add it as a module with a specific, specifically given with this is not according to the EN. So you use it on your own responsibility, and if it's okay for you. But the thing is with the tanks, those agitators are quite often there. So yeah.
I fully agree. Thanks a lot for the question.
Thank you too.
Anyone else? All right. I think as Karina already addressed, we recorded the session, so I think that we can make the recording available through a link to everyone who participated. If there are any further questions, don't hesitate to drop us a line. I see that Jasper is raising his hand.
Yes, so maybe one question that is the inverse of what kind of new things would you like to see? What's the thing that you dislike the most or that you struggle the most with when you're using Amphora?
You're asking us, or you're asking?
No, I'm asking the ones that are already currently using Amphora. What is counterintuitive to what you're used to in other tools, for example? What is, yeah, do you have those kind of things that can help us make the experience that you have with Amphora also better and easier?
Well, Jasper, thank you very much. You kind of remind me of some conversations I already had with Dante during this year. And maybe this could be to align the sketches and the symbols used there with the code. That will help a lot. I mean, I see you have your internal, thing going for 10, 20 years. So you're used to some symbols and stuff like that. But if they're aligned to the standard, the sketches, the abbreviations, etc., that will be a lot easier for someone like me who started using Amphora for a year. Yeah, thank you.
Thank you. All right. I think once the recording is available, we will send it out to everyone so they can take a look for themselves if needed. Drop us a line today if you have any objection against it, but we're going to try to submit it within the next few days. Then I think we can also send out the presentation to people here, because if you want to have a read through it again. And of course, we're always available if you want to reach out for any questions, whatever direction, just let us know. We're very happy to help. And based on the poll results, I think Dante's going to be busy with horizontal tank development.
Yeah, I know what to do. I want to especially thank Jasper as well for all the support and all the things he's been helping us out with. Without him, this wouldn't have been possible. So thanks a lot, Jasper.
And thank you all very much as well. Have a great day, and I hope to speak soon.
Okay. See you. Thank you. All the best.
Reynard, yes, I believe you will meet with our managing director, Erik. So yeah.
Yeah, Reynard, we'll get in touch with you separately from this meeting. Thank you very much.
All right.